the original problem is a little more complicated than what you might have seen on the thumbnail, so we have to find the smallest value of the expression, provided that x and y satisfy the equation you have seen on a thumbnail. So we're going to solve it anyway. We will start with saying that sine of x and sine of y are both not equal to 0, which means that I can multiply both sides by sine x times sine y, which is not equal to 0, and I will have sine of x plus y equals sine x plus sine y. Now for that equation we could use a formula of a sine of a sum, but that wouldn't lead to anything meaningful. And the idea here is actually using two other formulas. First of them is sine of a double angle, which is kind of unexpected because we don't have a double angle in that equation. And the second formula is a sum of sines, which is not that widely known formula. So I'm gonna prove it at the end of the video. And for a sum of sines, we have that, cosine over alpha minus beta over 2. So obviously we're going to use that for the right hand side, which will give us 2 sine x plus y over 2 cosine x minus y over 2. And now we see that relative to x plus y over 2, x plus y is a double angle, so that's why we're going to use that formula for the left hand side. So we will have 2 sine x plus y over 2 times cosine x plus y over 2, and I'm going to subtract the right hand side from the left hand side, and I will have 0 here. So now we can factorize the left hand side, sine of x plus y over 2 times difference of cosines minus cosine of x minus y over 2. And this product is only equal to 0 if one of the factors is equal to 0. So sine of x plus y over 2 is equal to 0, or cosine of x plus y over 2 minus cosine of x minus y over 2 is equal to 0, which is the same thing as saying that cosines are equal to each other. And since I said or, I have to draw an opening bracket here, which stands for logical OR. So for that equation, we're going to have x plus y over 2 is equal to pi k, where k is an integer. Because if we draw a trigonometric circle, then we see that an angle should be here or here in order to have a sine which is equal to 0. Now, to solve that equation, we have to say that cosines are equal if the angles are equal or if the angles are opposite to each other. And of course, adding period any integer times wouldn't hurt that equality, so we have to add 2 pi k here and plus 2 pi k over here, and another bracket here. Now, we can only solve that equation for a sum of x and y. So x plus y equals 2 pi k, where k is an integer. From that equation, we can find x, because x over 2 is at the left-hand side and the right-hand side of that equation, so it cancels at both sides, and we can find y. And y is equal to 2 pi k, where k is an integer. The same thing happens to y at the second equation, so we have minus y over 2, we can cancel that and have x equals 2 pi k, where k is an integer. So these are 3 solutions of that equation. But sine x and sine y are both not equal to 0. So these 2 solutions are wrong because 2 pi k is a point where sine equals 0. So we're left with x plus y equals 2 pi k. And now let's get back to our expression, since we have to find its smallest value. And if we look closely at that expression, then we can see that we can factorize that, because x squared plus 2xy plus y squared is just a square of a sum, and these 2 terms have a common factor of minus 5 pi. So this expression is equal to x plus y squared minus 5 pi times x plus y. We can now just plug x plus y equals 2 pi k in the expression, and we will have 2 pi k squared minus 5 pi times 2 pi k. And if we open the parentheses and factorize that expression, then we're going to have 2 pi squared times 2k squared minus 5k, which is a quadratic function with respect to k. And the smallest value of that function is reached at its vertex, So we have to find k vertex, which is equal to 5 over 4, which is not an integer, and k is supposed to be an integer. And we have to plug k equals 1 and k equals 2, but obviously k equals 1 is closer to the vertex, so we only have to evaluate that. So at the end, we will have 2 pi squared times 2 times 1 squared minus 5 times 1, which is equal to minus 3, and we have the answer minus 6 pi squared. So that's the smallest value of the expression provided that equation. And now let's get to the formula that I promised you. So the formula is a sum of sines, and sine alpha plus sine beta equals 2 sine alpha plus beta over 2 cosine alpha minus beta over 2. And to prove that formula, we're going to use two other formulas, sine of a sum and sine of a difference, and they look like that. And if we add these formulas together, then we're going to have sine x plus y plus sine x minus y equals 2 sine x cosine y, because these two terms add up together and these two terms add up to 0 because they're opposite. And now if we let x plus 1 equal alpha and x minus 1 equal beta, then we can find x and y. So adding these two equations, I will have 2x equals alpha plus beta, and subtracting these two equations, I will have 2y equals alpha minus beta. So x equals alpha plus beta over 2, and y equals alpha minus beta over 2. And if we plug that in here and that in here, then we're going to have the formula. So thank you for watching this video. I hope you learned something new, and if you did, watch another one. See ya!